excited about the fact that I'll make the homework live, depending on how far we get today, because it does go into 15.2, comparing multiple populations, and I don't want you trying that like blindly. So I may not actually make the homework live. So we'll deal with that. Like things will start to slow down a little bit at the end of the year. Math, not so much, but eventually we will. But what I'm trying to do when I combine the homework assignments is give you less assignments and less questions, less time spent to be able to show your skills. So if I can give you one 14-question assignment as opposed to two 11-question assignments, I'd rather condense it. So that's my goal when I combine those assignments. I know some people talk about that frustrating them previously. Our orchestra people. Hi, hello. Too bad you're not here. Sorry, guys.
They'll be here in like 5 minutes.
So they should be back soon. So when we talk about measures of variability, what does it mean to vary? And not V-E-R-Y, but V-A-R-Y. Very awesome.
To be different.
Good afternoon. Ben B. Saul, please stop by the office. Ben B. Saul to the office, please.
Have difference, have change. Any well, for things to be different, there would have to be multiple of them. So yeah, sure, we'll go with that.
Diverse, different.
Yeah, so again, different or diverse group. So when we have a data set, if it's all the same, something weird has happened. Like, if we're talking about heights of 7th graders, we're not going to get all the same data. We're talking about weights of dogs. We're not going to get all the same data. So we are going to have variability. Variability in simplest terms is the spread. Or the spread of the values in the data set. We want to be a little bit more specific. So variability, how far does it spread? Our variability in heights of 7th graders would be from, where would we start?
The shortest person.
The shortest person, and we would end
The
the tallest person. That difference would tell us the amount of variability. So, again, to do this, I need to know my minimum, and I need to know my maximum. I don't necessarily have to have them lined up in order, but that would help me. So when I look at the variability from -5 to 11, I say, what's the distance between them? It's 16. Remember, minus a negative makes plus a positive, so distance is always positive. If you get a negative answer, you've done something wrong. So take your larger value minus your smaller value, your lower value, and that will give you your variability. Now, quartiles. This is where everybody starts to get screwed up. My wife included. She hadn't done this for a long time. She's back in school for stats, she's taking a stats class. What does quart, or QUA on most occurrences, what does that mean? Or how many quarts are in a gallon? Andrew? 4, right? Andrew said, obviously. So, my quartiles, I would like you to highlight this, please. Divide the data into 4 parts, which does not mean you'll have 4 quartiles. You'll only actually have 3, because you'll have 3 dividers that make 4 sections. Think about a big rectangle. You want to cut it into 4 pieces. If I cut once, I've now got 2 pieces. If I cut twice, I've now got 3. I cut 3 times, I've got 4. So think about the blue box as being your entire data set. So that blue box is your data set. We are going to end up with what we call quartile 1, quartile 2, and quartile 3. Those are going to be, this would be a good thing to draw. Those are going to be the splits in our data. The interquartile range, what does inter mean? Between or within. Range, difference. Quartile, well, we're working with quartiles. The interquartile range is Q3 minus Q2. Or Q1. We're going from the top quartile to the bottom quartile. And actually, we use subscripts. Have we talked about subscripts in here yet?
No.
So a subscript is an identifier. It doesn't do anything other than identify. So this becomes Q3. Hey Colin, it'd be pretty good if you hang out for a couple more minutes to get the gist before you head out.
Okay, sorry.
It's okay, I just don't want you missing like the core of what we're doing. So they've identified, we'll talk about how to split your data. They've identified first quartile, second quartile, third quartile. Their first to third, -1 to +9, that range is 9 between them. Sorry, that was my brain getting ahead of me. The range is 9. I go from -1 to +8. That makes a range of 9. So if we were going to put our data in this box, we would have a -5. Then I'd have a -1 on the line, then a 4 between, then a 7 on the line. So that's kind of hard to see. It's just changing over. -1, 7, the 8 also on the line, and this 8 between, and this 11 out here. Notice things are split up symmetrically. If I look straight down the middle, I have 3 numbers, 1 in the middle, and 3 numbers. If I look only at the left half, so ignore the right half, I have 3 numbers, 1 in the middle, 1 on the left, 1 on the right. If I look at only the right half, I have 3 numbers, 1 in the middle, 1 on the left, 1 on the right. When we're splitting quartiles, everything has to be symmetric. So depending on whether we have an even set to start or an odd set to start, will change how I split up my quartiles. So this is why when I realized that we didn't get through 15.1, I said we probably won't get to 15.2. This is a little bit complicated to deal with. So we are given, what is this?
That's too much stating.
I'm so sorry, I do it all day long. We're given, and you have something to lean on back there. I had nothing, except for this chair. I use this very little as a chair. I don't know if anyone's realized how little I actually sit down. I can't sit down. I can't like stop myself. Huh?
Are you ADHD?
Never diagnosed, never tested though. So yeah, could be diagnosed. You have to have a doctor diagnose it. So back in my day, it was not like, oh, take your kid to get tested. It was, hey, sit down and shut up, do your work. Like, it wasn't, oh, they might have a problem. It was like, do your work. Like when my parents would just be like, okay, go run around outside and play, then come in and work. Like, it wasn't, we are going to take you to the doctor and try to get a diagnosis, because that wasn't as prevalent. It just wasn't as common. So who knows? I might be. Never know. What is this? It tells it to you, but who remembers, Julian? Box and whisker plot, right? So this, we want to box, whisker.
Okay.
Yeah,
You've never seen it before? Okay,
We've seen it before. I've just never heard it.
Okay, so we are going to place out some identifying factors for our box and whisker plot. And we might as well use this space up here. So draw yourself a little box and whisker plot. Make sure there's a point on the end. Do your box in the middle, you're going to have a line somewhere, and then a whisker onto the right side. They really call it box and whisker because there was no better name.
What about Mr. Robot?
Yeah, that wouldn't make sense. So, here's how we label the box and whisker. Here's the data that it communicates. What do you think this far point down here would be?
Your bias.
Think about how a number line works.
Oh, yeah.
That'd be my minimum if we're going to use math words. That's my minimum. Which would mean that this point out here would be our maximum. And then this box actually communicates to me. Can you put that label down? Because 1, it's making noise, and that's annoying, and 2, it worries me. You might suffocate. Playing with it next to your math. These are quartile 1, quartile 2, and quartile 3. So the distance between the edges of the box is your interquartile range. Now, don't let that big word scare you. All it means is distance. What's the distance within the box? So, down here, we need to identify, find the range and interquartile range of the temperature. Well, to find the range and interquartile range, We first have to list out what values do we have. So, we are going to set up, please off to the right here, make yourself a little table. We're going to do minimum, maximum, Q1, Q2, and Q3. When you look at the number line. Oh my gosh, so many people not here today.
So perfect.
We
have like a really nice long.
Well, we have so many. Oh, Ellie, you're over here today. Ellie, what are the minimum and maximum if you try to approximate based off this number line?
The minimum is about 145.
Yeah. We're real close to right between there, so we might as well say 145. Yeah, 201, 202, something around there. Mr. Hoover, what about quartile 1? Where do I look to find that?
That's the first line on the box.
Yeah, the left edge of my box. What's that look like? Sure, works for me, 155. My quartile 2 is actually the median of the data. So quartile 2 is your absolute middle point, which here is pretty obvious. It's right above a line on the number line.
Always your median?
Quartile 2 is always the median. They are synonymous. They are the same thing. So actually, some data sets give you min-max quartile 1, median quartile 2. So if you want to off to the side, like write yourself a little note, this is median as well. And then Jeremiah quartile 3
187.
is 180. You know what? I'd even go a little bit higher than that probably. I'd say at least 188, if not 189. Let's just go with 188. It's really close to that 190. So now, to find our range.
You subtract that. Get the highest and the lowest and subtract it.
Range, not IQR, range just comes from your min and your max. So to find my range, take the maximum of 2. So I'm going to put R for range. 202 minus the 145 gives me 57. Now, if your interquartile range is somehow bigger than your range, you've made a mistake. Because think about it. Range, full distance, interquartile range, box distance. So my interquartile range is going to use Q1 and Q3, and actually Q2 gets no love here. So we use 188 and 155. 88 minus 55 gives me 33. So then we have to use this to describe our variability. So we could say what's a hot spring? How much it changes. So if we were to make a statement about the variability of these hot springs, what would you say? How would you communicate this data? You can probably do it. If you understand all this, you can probably do it. Yeah, but what about the variability? Monica?
The variability from the lowest point to the highest point is 57.
Yeah, so we could say the hot springs, this is writing really low for me, the hot springs can vary, V-A-R-Y, by 57 degrees from min to max. So 145 is hotter than any hot tub you've ever been in.
The awesome hot
202 is almost boiling.
Can you throw back around?
Now, here's what I want to clarify with you, Mr. Smith. This is not a temperature. That's the distance between temperatures. 57 is really cold. Go somewhere in a 57-degree pool. That's not a temperature. That's the change in temperature. Does that make sense? From the lowest to the highest has that distance, but we're not saying that the hot springs are going to be 57. That's the distance between. Does that make sense?
They can't be 57 because the
That would not be a hot spring. Yeah, that would not be a hot spring. Sean?
What is a hot spring?
It is water that is naturally heated by vents that come up from the like where seismic plates have cracks in them, and the hot air comes up from the molten lava in the center of the earth. Like they are waterways heated by that steam. So they'll even have they'll look like they're bubbling, and it's not boiling. It's the air from the vents coming up through them. Now the dangerous thing is some hot springs are toxic because those vents have so much sulfur in them that the gases coming off the water can actually poison you. It's just common knowledge that some hot springs are.
Wait, is it
There's normally areas set up like this is a safe hot spring area. This is off limits due to sulfur. Like, they'll have signs posted.
Is it
Will
poisonous?
you guys
Is it
get
poisonous?
the water tested?
Yeah, people will come out and test the air, test the water, and they know you can figure out where the vents are coming from, and it doesn't change. Unless there's a big earthquake or something, the vents stay the same. So if it's safe today, it should be safe next week. It should.
So we get that from the range, right?
We get that from the rain because it asked for describe the variability.
Okay.
Now, if we want to say the middle 50%, because when we break things up into fourths, I have a fourth of my data here. I have a fourth of my data here. A fourth of my data here, and a fourth of my data here. We could say that the middle 50% only has a variability of 33 degrees.
Middle 50%.
Because this is 25%. This is 25%. This is 25%. This is 25%. Because all of our data has been broken into fourths. Fourths are 25%. So if you want to talk about the middle 50%, cut off the lowest 25%, cut off the highest 25%, only look at the center of your data, then you could say the middle 50% only has a variability of 33. But that would not count the lowest values and the highest values. We kind of got rid of those to ignore them.
Is the air toxic or is it the water toxic?
Could be either, depending on how you can look this stuff up. If you guys are interested, I always encourage you to go do research beyond class. So we have these depths of hot springs. What's actually the other thing is how far away is the vent from you, because it could physically burn you as it comes out. So if the vent is really shallow, you wouldn't want to get that close to it, but the vent is 20 feet down. That air's got 20 feet to kind of cool down before it hits me, before it gets out of the water. So if you put your foot on a hot spring, it could potentially melt your foot off.
Oh.
Or not a hot spring, like a hot vent. So talk to Gabila if you want to know more about this or go research them. It's pretty cool. I had a friend who went to Iceland on a choir tour, and Iceland's this cold place, whatever. It's ice. No, that's actually a misnomer in a way. But they took a picture sitting in a hot spring, where it is not a hot tub. They're in rocks outside, no pipes, no electric, no anything, and this water is bubbling hot because of vents releasing the hot air from in the crust.
I think we did that when we went to Japan when I was 10. There was a onsen that was kind of like that. It
Yeah.
was like hot spring.
So in order to figure out the interquartile range, I'm going to need to know my quartiles. Before I know my quartiles, I got to order my data. So the first thing I'm going to do, order your data. So lowest is going to be 6. My next 23.5. My next appears to be 25, and I've got 2 of those. And then 27. And 32 and a half. Now I need to find the middle. Always double check that you've used every data point. I have 1, 2, 3, 4, 5, 6. I have 1, 2, 3, 4, 5, 6. Perfect. Now, when I have 6 data points,
25 and 25.
my middle, like we talked about finding the median, is here. What's the average of 25 and 25? No. How do we average?
You add the two up and divide by 2. Oh, okay, here. I don't know how to do it.
And then divide
The
them
average of two things that are identical is what they are, because there's no difference between them. Hey, shh. Brain farts happen to all of us. It's okay. Now, hold up. Here's the part where people get confused. Was that 25 one of my numbers? Did I use one of my data points? There was not a number in the middle, so this Q2 just kind of sneaks its way in the middle, and it does not use either of my 25s. So now, when we look at the left half, I still have 6, 23.5, and 25. Can I find a middle of my left half now? 23.5. This is now my quartile 1. Can I find a middle of my right half? So this is now my Q3. We would have our min if we want. And we would have our max if we want. And we have everything. So now, to talk about our interquartile range, I just go from quartile 1 to quartile 3. What is my IQR? Yeah, this is a different software than when I started at the beginning of the year. Sean? 3.5. Which tells me this data is really close. If my interquartile range is only 3.5, that's very close together. So here's another new math word for you. Since most of my data is pretty close together, what do I call a point that doesn't seem to fit? Sean? Close. An outlier. So, hold up. We don't know for sure. There's a technical way to test this, but what we would say is this might be an outlier. There's a technical way to test this. We will eventually get there, but that might be an outlier. It's pretty far away from my other values. Think about it. This distance is only about 5. It's 5.5. This distance is pretty big. It's like 17. Pretty big. Pretty big. The chef. I forget what his.
Chef Boyardee.
No, the chef from the Muppets. You guys never watched the Muppet like
I
Christmas
see
special?
that.
Every winter we watch the Muppet Christmas special. Where they're in that you know the Muppet Christmas special, right? Are we out of time?
No, not at all. I'm just looking around.
I need to check when we're done. Somebody stole my schedule. Try to work through this example. We want to find the median and the range for each airline. So these are separate data sets. We have 2 data sets. We want to find the median and the range for each of them.
Oh, it's already.
Shh. No, it's not.
Oh, yeah.
Don't say things that aren't true. Oh, snap, old. I have you guys for a while. Sweet. We're here till 42. Only like 20 minutes. I'm sorry.
Is this an hour-long class?
No, it's only 45. It's just after lunch, so it feels slightly longer because you're kind of lethargic and tired. What's up? These are 13-1. You should have these.
I've answered.
Oh, sweet. So, I was actually about to come to you because we called on your card when you weren't in the room with us. So, Jasmine, what's the first thing that I should do with Beta Air or Park Air before I start this?
Put them in order.
Order it! So, if I order my Beta Air, what's my first value?
399.
Yep, my next one.
400.
Then,
402.
then,
413.
thank you for not saying and then,
722.
so then we'll let you finish up Beta. How do you find your median and your range?
To find the median, we just look for the number in the middle, which is easy because it's an odd list.
Ooh, because it's an odd list, I have a number dead middle. That used to be my Boy Scout troop.
And then
402 for life.
to find the range, you take the highest and the lowest number
Ah,
and
so-
subtract them.
we're asking what's the difference? Which is range. Which is
323.
323. So what this tells me, kind of doubt that we have all this written down yet. What this tells me is the range in prices varies $323 between the lowest flight cost and the highest flight cost, and the middle flight cost is about $400. This guy seems like a potential outlier. Maybe that's like the time of day that you actually want to fly, like in the middle of the day. Normally the cheaper flights are like in the middle of the night. Because it's like, well, people don't really want to get to the airport at 3 in the morning, but, well, we got to fill this plane and move. So they cheapen up those flights, and the flight where I might get to the airport at 10 in the morning, I can sleep in a little bit, I can direct, that might be more expensive, so I'm flying in the middle of the day. So let's do the same thing. I'm going to capture and delete this so I can do it over again. For Park Air, wait, what? If I do 722 minus 399, I'm sorry, can you identify it and not do it in the future? There, then it was purposeful. For Park Air, Whitney, you want to help me out with Park Air?
Yeah. Should to order it, which would be 398,
398,
409,
409,
428,
428,
447,
447,
465.
465.
And then the middle would be 428.
My median value is just that 428. So if I was going to compare medians, which airline has a lower median? Beta Air did. But when I go and look at the range, Whitney, what'd you get for the range here?
67.
So this range, the difference in their prices is only 67. If you are going to choose an airline to look at their prices, which one would you choose and why? There's not a wrong answer here. I'm curious what you say. Jeremiah?
I would choose Beta just because they have the biggest difference in prices, and like there could be like something more for you, maybe.
So let me push back a little bit. Is variability in price a good thing?
You want it to be sort of in tight groups, just so it's a little bit more consistent. But if you have it in bigger groups, you have a larger price range and like a larger crowd that you can draw in.
So variability in price can be a good thing, right? So that it gives people some choice, gives people some options. But so maybe Beta Airline offers a first class seat where Park Airline doesn't. But what if these were for the same flights? Beta and Park both fly, let's say Ohio to California. These are all Ohio to California. These are all Ohio to California. when you're looking at who am I going to book through, would you rather have a $300 range where your price could swing, or a $70 range where your price could swing? Yeah, this is probably a little bit safer. But on the flip side, the median prices, 402, that one's lower, the middle price, versus this one's a little bit higher middle price. So you can kind of make an argument on either side depending. Oh yeah, you do. When you look at I want to fly from here to there, you get a list of flight options. Sometimes you do. Because you have to weigh out, what do I actually want here? With the median price, maybe I just get a seat and coach and I get some nuts. Like a bag of nuts, right? Like, maybe a drink. In the 722 seat, I get a seat that reclines all the way, that I can take a nap, I get Wi-Fi access, and I get free a free meal. So you do some comparison shopping. You don't realize it yet, but this stuff does come back around. And you don't always think about, oh, let's calculate the median, let's calculate the average. But you do those things. Like, once you are a mathematically minded person, you do those things automatically. Where you compare what's the range on this airline and the range on that airline. Well, that airline has a huge gap between lowest and highest. This airline's a lot tighter. It must be more consistent. So various things that we can talk about dealing with consistency and range and all those sorts of good things. So Data Girl wants to buy a suitcase for her next trip, and she wants an unusual color. My suitcase has stripes and polka dots at the same time. I know it's my suitcase. She wants... she records every third suitcase. What is it if she records every third? Systematic. That comes by on the baggage claim. So she sees blue, skips to black, skips to black, skips to blue, green, black, green, blue, red, and so forth. The store Data Girl shops at sells black, blue, red, and green suitcases. Which color suitcase should she buy based on your data? Sam?
Red one.
Why?
Because it's not as common as a blue.
Excuse me, red, because based on our data, it is the most uncommon. So it's bringing back in a little stats question from earlier, or the previous chapter. Any questions on range, interquartile range, all that good stuff? Yeah.
Recording every third of the suitcase make it so that there's a chance that, like, in between, like, one suitcase and then the third one, there could be two red ones.
They're good. But a systematic sample, unless you know that your data is ordered, like by color or whatever, which it's not. Those flight attendants or the baggage handlers just threw the stuff on there. They did not put it in order. Then we can assume that since there's no order to the data, that systematic will give me a fairly representative sample. It could have a slight bias. We can't do anything to completely cancel out bias. There always could get some bias in there. But systematic, when my data is random, should work to cancel out bias as much as possible. If you're worried about that, take a bigger sample. Yeah, so if you're worried about bias, take a bigger sample.
I would do, like,
Any other questions? Joey? No. You want it to be rare. So the worst, she's looking at suitcases on the baggage claim belt. These are suitcases that people own. Not she's looking at suitcases in the store. Does that make sense?
You're at the airport.
So the worst possible thing that can happen while you're traveling, okay, maybe not worst possible, I'm being dramatic, but is somebody else picking up your bag. Because you don't know where they're going.
When I went to Georgia.
Yeah, so all of a sudden, what you thought was your bag that you're standing there waiting for goes with a dude, hops in a taxi, and goes to the other side of town. Then, once they realize, oh crap, I've got the wrong bag, then starts the entire process with the airlines of them picking up the bag and getting it to you and everything else. On the way to California, when I was out for a couple days earlier in the year for that wedding, my brother's bag got lost. Between Chicago and California, because they flew to Chicago and then flew to California, bag got lost. The airlines are then responsible. They're legally responsible to get you your bag, like when and they aren't responsible under any certain timeline, is the annoying thing. So we were waiting. Finally, at like midnight, they showed up at our hotel with his bag because they found it and they bring it to you then. So it's their responsibility. But if somebody else took it, you're now dealing with another person. So this is where statistics come into play of when I look at the conveyor belt and I see black and blue and green and stripes and polka. When I went and bought my luggage, I made a statistical observation in my head and said, you know how many suitcases are polka dotted and striped at the same time? Not very many. So when I went to the store and I found that, I said, this is rare. I'm going to buy this. I also then bought some tags that said, this is not your bag. Literally, that's all the tag says, is this is not your bag. And on the flip side of it, it has my information, so if like somebody picks up my bag accidentally, but I made it as unique as possible. And I never travel with anything that I really care about. Then I would not fly. I would rent a truck. So y'all are in here till 42. So let's talk about probability for a minute. What do you think is the probability of you getting caught by the Google Earth camera?
Oh,
Did he show you?
Yeah.
So talking about probability, what do you think the odds are of getting caught by the Google Earth camera?
Not very many.
Not very common, right? Because let's look at everything that would have to happen. He'd have to compute the probabilities of what all things would have to happen. So the car has to be by me. Also, I have to be outside or visible.
10 crimes that were caught on Google Earth.
Yeah, so there's other things too. But so still in our discussion about probability, what do you think is the probability of you knowing somebody captured by Google Earth? Do you think that's higher or lower than the probability of you being pictured? Higher, right? It is harder to end up in the picture than to know somebody in the picture. Right now, you're experiencing that. You've not been captured in a picture on Google Earth. Yet, all of you now know someone who's captured in a picture on Google Earth. So, when you look at probability in situations, think about, well, how many people actually get pictured on Google Earth? Not very many. Think about how many people know those people. Well, lots more people know them than are them. So that's where the probability things kind of come into play of real life situations. This was really interesting. Mr. Kabila sent this last night, and he said, like, it's my dream, I got a Sasquatch picture. Because if you look up pictures of Sasquatch, a lot of them look like this, where he's walking and you can't see his face. But my response to that was, that's such a good probability example. Like, what's the actual odds? Very, 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 very slim. Yet, it can happen. Right? It doesn't mean it won't happen, it just means it's very, very rare. And it's very, very
If it's very late.
let's